All right, let's do another example of finding the interval of convergence for a power series. This is the sum from 2 to infinity of 5x to the n power. So once again, we will use the root test. We'll find the limit as n approaches infinity of the absolute value of 5x to the n power raised to the 1 over n power. And once again, n times 1 over n just gives you 1. So this is the limit as n approaches infinity of the absolute value of 5x, and that's a constant as far as n is concerned. So that limit is just the absolute value of 5x. So I did get an L, I got an answer. And I know that the original series will converge as long as L is less than 1. So I need the absolute value of 5x to be less than 1. That is, I need negative 1 to be less than 5x to be less than positive 1. Divide everywhere by 5. So it looks like x is between negative 1/5 and positive 1/5. So I know the series will converge for any values of x between negative 1/5 and positive 1/5, but I don't know what happens at the endpoints. So I do need to check those separately. So let's do it. All right, so first, if x is negative 1/5, I have the sum from 2 to infinity of 5 times negative 1/5 to the n power. And again, that's the sum from 2 to infinity of negative 1 to the n power. Once again, that's, in this case, we're starting with n equals 2. So that's 1 minus 1 plus 1 minus 1 plus 1 minus 1. As we talked about in the previous video, that diverges. So, no colored in circle here. If x is positive 1/5, we get the sum from n equals 2 to infinity of 5 times positive 1/5 to the n power. And once again, just like the previous problem, that's just 1 to the n power, which is 1 plus 1 plus 1 plus 1 plus 1, which also marches off to infinity, admittedly very slowly, but it still diverges. So, again, in this case, neither endpoint works. So this particular series converges as long as x is strictly between negative 1/5 and positive 1/5.